Good day, esteemed researchers and curious minds tuning in from around the globe. Today, we delve into the fascinating world of language models as problem solvers with our study, Tree of Thoughts, Deliberate Problem Solving with Large Language Models. We challenge the current paradigm, exploring beyond text generation, and propose a novel framework that draws inspiration from human cognition. Stay tuned as we unravel how this approach outperforms existing methods in tasks requiring search or planning. Let's embark on this intellectual journey together. Our research delves into the potential of language models, such as GPT-4 and PaLM, as problem solvers. We question whether the simple autoregressive mechanism which these models employ is sufficient for complex tasks. This mechanism is akin to the system one-foot mode of human cognition: fast, automatic, and unconscious. However, it falls short in tasks requiring search or planning, and struggles with maintaining and exploring diverse alternatives, as well as making global decisions. To address these challenges, we introduce the Tree of Thoughts, or TT, framework. This novel approach allows for problem solving with language models in a more systematic and deliberate manner. The 2T framework maintains a tree of thoughts, where each thought is a coherent language sequence. This high-level semantic unit allows the language model to self-evaluate the progress different intermediate thoughts make towards solving the problem. To explore this tree, we employ search algorithms like breadth-first or depth-first search, enabling systematic exploration with lookahead and backtracking. Our evaluation and results reveal the effectiveness of the Trees of Thoughts 2T approach. We tested TT on 3 new problems using the state-of-the-art language model, GPT-4. The results were superior across all tasks, demonstrating the potential of this approach. We didn't just stop at the results. We delved deeper into the process, considering the progress of different intermediate thoughts and how various factors affect model performances. This allowed us to gain a more nuanced understanding of the strengths and weaknesses of our approach. For instance, in a creative writing task, 2T was found to generate more coherent passages than other methods. This was confirmed by both automatic GPT-4 scores and human judgments. In essence, our research not only presents a promising new way to use language models to solve complex problems, but also provides a comprehensive evaluation framework to understand the dynamics of this approach. Our research is driven by the exploration of language models as problem solvers. We question whether the autoregressive mechanism of language models, which generates text one token at a time, is sufficient for complex problem-solving tasks. To address this, we draw inspiration from dual process models of human cognition, which suggest 2 modes of decision-making: a fast, automatic mode and a slow, deliberate mode. Now let's look at the figure. It provides an overview of our proposed Tree of Thoughts, or 2T framework. In this framework, each rectangle box represents a thought, which is a coherent language sequence that serves as an intermediate step toward problem solving. This approach allows for a more deliberate and systematic exploration of possible solutions, much like the slow, deliberate mode of human decision-making. This is a novel approach to problem solving with language models, and we believe it opens up exciting new possibilities. While language models like GPT-4 and PaLM have shown impressive capabilities, they operate in a manner akin to the system one-foot mode of cognition: fast, automatic, and unconscious. However, this approach may fall short when dealing with tasks that require search or planning. To address this, we introduce the Tree of Thoughts, or TT, framework. This innovative approach allows language models to maintain and explore diverse alternatives, enabling them to make more global decisions. It's like adding a system 2-feet mode of cognition, slow, deliberate, and conscious, to our language models. We've put this framework to the test with 3 new problems: the game of 24, creative writing, and crosswords. These tasks require a range of reasoning abilities and a systematic approach to planning or search. The results? The TT framework outperformed existing language model inference methods, showing its potential to revolutionize how we use language models. Our research introduces a novel approach for problem solving with language models, which we call the tree of thoughts, or 2T framework. This method draws inspiration from planning processes developed in the 1950s. The TT framework operates by maintaining a tree of thoughts, each representing a coherent language sequence that serves as an intermediate step towards problem solving. To navigate this tree, we employ search algorithms such as breadth-first search or depth-first search. These algorithms allow for systematic exploration of the tree, providing the ability to look ahead and backtrack as needed. This approach offers a promising new way to harness the power of language models for complex problem-solving tasks. Our research introduces a novel framework called trees of thoughts, or TOT, which marries the capabilities of language models with search algorithms. Each thought in this framework is a high-level semantic unit, and we implement search heuristics via the language model's self-evaluation. We put this framework to the test with 3 tasks: the game of 24, creative writing, and crosswords. These tasks were chosen for their requirement of various reasoning abilities and systematic planning. All experiments were performed using GPT-4, the state-of-the-art language model. Our technical findings were quite promising. We observed superior results on all tasks when compared to existing methods. The TT framework supports different levels of thoughts and search algorithms, providing flexibility in its application. Through systematic ablations, we were able to analyze how different choices affect performance, leading to valuable insights for future research. In essence, our research pushes the boundaries of what language models can achieve, opening up new possibilities for problem-solving and planning tasks. In our study, we put the tree of thoughts, or 2T, framework to the test on 3 challenging tasks: the game of 24, creative writing, and crosswords. The results were quite impressive. 2T not only outperformed existing language model inference methods across all tasks, but also showcased its flexibility and generality in accommodating different problem-solving requirements. What makes 2T stand out is its ability to generate and evaluate a variety of thoughts, effectively adapting to the unique nature of each problem. This adaptability is a key strength of 2T, enabling it to tackle a wide range of tasks with varying complexity. In essence, our results highlight the potential of 2T as a powerful tool for problem solving, capable of outperforming state-of-the-art methods while also demonstrating remarkable flexibility and adaptability. In our research, we've introduced a novel framework for problem solving with language models, called the Tree of Thoughts, or 2T. This framework maintains a tree of thoughts, where each thought serves as an intermediate step towards solving a problem. To navigate this tree, we employ search algorithms like breadth-first or depth-first search, allowing for systematic exploration. Now let's take a look at the figure on the screen. It showcases the performance of the 2T framework on one of the 3 new problems we proposed: creative writing. The results are quite promising, demonstrating the effectiveness of our approach. We tested the 2T framework on 3 tasks that challenge existing language model inference methods: the game of 24, creative writing, and crosswords. In all these tasks, TT outperformed the existing methods, proving its potential as a powerful tool for problem solving with language models. In conclusion, our research contributes to the field by offering a new way to use language models for problem solving. And we're excited about the potential applications and future developments of the 2T framework.